Hey guys, so today we are going to discuss the question called as course schedule. So this is a Leetcode medium question, and this is also a very important question because this question involves a very important algorithm. So let's start reading the question. So there are total of n courses you have to take labeled from 0 to n minus 1. So you are given an array prerequisites where prerequisites of I will be AI comma BI, which indicates you must take course BI first if you want to take course AI. So what they're trying to say is they'll be giving you will be having n courses. For example, let's say you have something to study and you have n courses, and they'll be labeled from 0 to n minus 1. So they will be also giving you an array which is called as prerequisites, which represents some pairs, where the pair represents, in order to take one course you have to take another course. For example, let's say in this, for example, the pair 0 comma 1 indicates that to take course 0 you have to take course 1. That's what this prerequisite array says. So return true if you want to if you can finish all courses, otherwise return false. So that's what the question requires. So let's take an example, so what they actually meant. So for example, let's say we have n is equal to 2, and maybe n is equal to 2, and we have a prerequisite array which looks like this, which is 1 comma 0. So as there are only two courses, right, so we have only two nodes. So let's try to build a graph. Let's try to take this relationship and let's try to build a graph. So as I said, 1 comma 0 actually means in order to take 1 you have to first go to 0, you have to first finish 0, right? So that means the relationship would be like this, 0, and then we have to go to 1, right? This is what the relationship. So now in general, if this is a relationship, if to take 1 first you have to go to 0, right? So in that case you will definitely go to 0 first. So you will come to 0th course and you will complete this course, and then you'll go to first one, the course with 1, and then you'll complete that course, and there are no more courses, right? So that actually means you can complete all the courses, which actually means you can just return true in this case, right? This is the possible case. So let's try to see what is impossible. So let's take same example but some small change. So let's say we have the same n courses, I mean two courses, where the one of the prerequisites would be 1 comma 0 and other prerequisite would be 0 comma 1, right? So now as we know we have only two courses, right, which would be 1 and another would be, I mean 0, and now it is 1, right? So now let's try to build the connections. So as we said, to take course 0 first we have to go 1, and to take course 1 first we have to take 0, right? So now the relationship would be like this, 0 to 1. So the second relationship would say to take course 0 first you have to take course 1. So this would be like this. So now with what course you have to start? If you take course 0, let's say we have start with course, I mean with 0. So now if you start with 0, but 0 has a prerequisite which is 1, right? So now if you, let's say if you start with 1, but 1 has a prerequisite which is 0, right? So this is something like an impossible case because it has a cycle. If it is a cycle, that actually means you definitely cannot complete any course, I mean all the courses for sure. So this is a base case. If cycle is there, that actually means it is impossible for sure. For sure it is impossible. Oh sorry, this is a spelling mistake. It is impossible. So in this case you can actually return false. So these are two cases, where one is possible case where you have to return true, and another is impossible case where you have to return false. These are two cases. So let's try to take another example and let's try to find how can we actually find technically. I said, right, we will be using an algorithm. I'll tell you how can you use that algorithm, and I'll tell you what algorithm we are going to use and how it helps us finding whether we can complete all the courses or not. So let's take we are having these 5 courses where num course is equal to 5 and the prerequisites are represented in the form of a graph. So these are the prerequisites which is represented in the form of a graph. So now, like if I give you this graph, with what course you are going to start? Obviously the one which doesn't have any prerequisite, right? So in this case, what are the nodes, or what are the courses which doesn't have any prerequisites, which is 4 and which is 3, right? So how are you deciding that doesn't have any prerequisite? Because it doesn't have any inbound edges, right? Obviously if the code doesn't have any inbound edges or incoming edges towards it, then obviously you're going to say it doesn't have any prerequisite. So how can we find the a node doesn't have any inbound or incoming edges? So generally the number of incoming edges for a node is nothing but the integrity of the node. So first things first, let's try to find out all the nodes and their integrities. So let's try to create some kind of a data structure maybe. So maybe I'll be using an array. So let's say I'll name it as integrity. So as we have 5 nodes, right? So I'm going to create it of size 5, length 5. So let's say it's 1 2 3 4 and 5. So as our courses start from 0, right? So it's going to be 0 1 2 3 and 4. So now let's try to fill this. So what is the integrity of 0? So for integrity of 0, the number of incoming edges is just 1, right? So it's going to be 1. So for 1 it's also 1. So for 2 it is 2 because the incoming edges for 2 is 2. So now for 3 it is 0 because it doesn't have any incoming edges. For 4 it is also 0. So these are the integrities of all the courses. So now, as I said before, we'll be starting with the nodes or with the courses which doesn't have any prerequisites. That actually means the courses or the nodes which has integrity 0. So in this case the integrity of 4 and 3 is 0. So what I'm going to do is, for this case I am going to create a queue. So I'm going to create a queue. So I'm going to put all the courses or all the nodes which has integrity 0. So initially 3 has integrity 0 and 4 has integrity 0, right? So now I have done all inserting all the nodes or all the courses with the integrity 0. So now I'll take one by one. So now I'll take 3 outside. I'll remove 3 from the queue, and what I'll be doing is I'll be taking all the adjacent nodes of 3. So in this case the adjacent nodes of 3 is just 2, right? So 2 is the adjacent node of 3. So now what I'll be doing is I'll be completing this course and I have to remove 3 from this relationship, right? If I complete this course, that actually means we don't need it at all later. So if I remove 3, the integrity of 2 decreases by 1, right? So I'll take 3 from the queue and I'll find all the adjacent nodes of 3. So in this case it is 2, right? So I'll take 2 and decrease its integrity with -1. So what I'm going to do is the integrity of 2 is 2, right? So now it becomes 1. So similarly I'll be taking the next one, which is going to be 4, right? So now it is 4. So now it is 4. So what are the adjacent nodes of 4? It is 2 as well. Again the adjacent node of 4 is 2 because 4 adjacent node is 2, right? So now I'll be taking the integrity of 2 and decrease it by 1. So even in this case, so what I'm going to, it is 1 now. So now it's going to be 0. So if it is 0, whenever we decrease the integrity of a node and if it becomes 0, then I'm going to add that node or that course to the queue. So as the integrity of 2 is 0, I'll be adding it to queue, because if it doesn't have a prerequisite, then that's the chance to take it, right? So we'll be adding 2 to the queue. So now we are done with 4 as well. So now we are done with 4. We'll be removing from queue, right? So the next one which is there with prerequisite 0 is 2, because we have removed this 4 and this 3 as well. So now the one which doesn't have any prerequisite is 2, right? So now we'll be taking 2 from the queue and do the same thing, which is finding all the adjacent nodes or all the adjacent courses and decreasing its integrity to 0. So now in this case the adjacent nodes of 2 are 1 and 0, right? So 1, which would be an adjacent node of 2, and another would be 0, right? So now I'll be taking the integrity of 1 and decrease it by 0. So now previously it is 1, right? So it becomes 0. Similarly for 0 as well. And for another thing which we are missing, if it becomes 0, we have to add it to queue, right? So that's the main thing. So I have added 1 to the queue. So now 0, if I decrease it by 1, it also becomes 0, because previously it is 1, now it becomes 0. So now even if it becomes 0, I have to add it to queue. So I'll be adding 0 to the queue. So as we have used 2 already, we have to remove 2 from the queue. So now the next one which we are going to take is 1, because it is in the queue, right? So I'll be taking 1 and find all adjacent nodes of 1. So as 1 doesn't have any adjacent nodes here, because it doesn't have any adjacent nodes, right? So that actually means there are no outbounding edges for 1. So we are done with 1. So we can just remove 1 from the queue. There's nothing to add inside the queue again. So we'll be done with 1. So the next one to take is 0. So I'll be taking 0 and do the same process again. I'll see whether it doesn't it have any adjacent nodes or some adjacent courses or not. So 0 doesn't have any adjacent courses, just like 1, right? So that actually means we are done with 0 as well. So I'm done with 0 and I'll remove it from queue. So now we are done with all the courses, right? All the n courses. So it actually means in this case we can just return true because we are done with all the courses. This is a possible case. And how can I return true or false? So what I can do is I can maintain a counter whenever I visit a node. Whenever I visit a courses, I am going to increment this counter +1. So if at all I'll come to a node, or I'll come to a course, and if I increase this counter, and by the end of the process, by the end of this entire algorithm, if at all the count is equal to n, that actually means it is true for sure. If the count is equal to n, it is true for sure. If at all the count is not equal to n, that actually means we haven't done with all courses, then it is false for sure. So these are the base case. This is the base case for this algorithm. If count is equal to n, it is true. If count is not equal to n, it is false. So the algorithm which we are using here is called as Kahn's algorithm. So you might have heard that before. It is called as Kahn's algorithm. It mainly deals with integrity and inbound edges, because we are trying to use the integrity of nodes, right? So it mainly deals with the integrities of nodes. So this algorithm is called as Kahn's algorithm, which mainly deals with topological sort, because we are trying to find the ones with the integrity zeros, right? So if you sort them like that, I mean, if we try to place them how we have visited these courses or how we have visited these nodes, and that path or that order is called as topological sort, right? So for example, in our case we have first visited 3, right? And next we have visited 4, next we have visited 2, next 1, next 0. This order is called as topological sort. So to find the topological sort, we can use Kahn's algorithm, right? So this is what the approach we are going to use. So let's try to implement this. Let's try to code this. So here we are having a method called as canFinish. So its return type would be a boolean where we return true or false. If true, then actually means we can complete all the courses, or else it is false. So it passes as none courses, which actually represents the number of courses, and the prerequisites in the form of an array, right? So first what I'll be doing is I'll be using n as a number of courses because it's a big name, so it would be easier for us to take using n. So now the first thing which we have done is finding the integrities of these nodes, or finding the integrities of these courses, right? So for that I'll be creating integrity array, so which is going to be of size n, and I'll be creating an adjacency list to make this graph, to make the relationships. So what I'll be doing is I'll be maintaining an adjacency list which would be of type list. So it's going to be list of list. So it's going to be of type integer, and I'll name it as adjacent. So array list. So now I'll be adding n lists inside this adjacency list. This is a mandatory thing. So adj.add new array list, right? So now what I'll be doing is I'll be traversing through these prerequisites and try to increase the integrities, and also try to build the graph. So it's going to be int, let's name it as p for each pair, and prerequisite, let's try to copy it, it's a big name. So prerequisite, so what I'm going to do is I'll be using u for p of 0, just for good understanding. So int v p of I. So now I'll be creating a graph. So adj.get v.add view. So v, in order to take you have to complete v first, right? So it's going to be like that. So u. So now, I mean, in order to complete you have to first take v. That's what I meant. So now also the integrity of u increases, because the edge would be in the form of v to u, right? So now v to u, in the sense the u has one inbound edge, so we have to increase integrity of u plus plus, right? So now this entire for loop is going to create our integrity array and also the adjacency list. So now as we have used a queue, let's use a queue here as well. So it's going to be of type integer. We are going to store integers, so let's name it as queue. And so now what we have done before, we have tried to insert all the courses or all the nodes which has 0 in degree. So let's do the same. Let's try to iterate to the given in the integrity array, and let's say, so if integrity of I is equal to 0, then just add it to the queue. If integrity is 0, then we are going to start with those nodes only, right? So now next, as I'll be using a counter to find at the end, I can just verify with that. So I'll be starting the process. So while q.size is greater than 0, we have to make sure if q is not empty or not. If it is empty, then we are done with the process. So what I'm doing is I'll be taking the first course or the first node inside the queue. So it's going to be, let's say, current. I'll be taking it out from the queue.poll, and what I'll be doing is I'll find all the edges, all the adjacent nodes for this current course. So adj.get current. So now, as I said before, I'll be decreasing the adjacent nodes in degree to -1. So what I'll be doing is, if minus minus in degree of v is equal to 0, then q.add v. So I'll tell you what it's actually doing. So first it will try to decrement the integrity of v and verify. After decrementing, it will verify it is 0. Then if it is 0, then it will add it to the queue. That's what it is doing. So if it is queue, it will just add. So and later I have to increment the count plus plus, because we have visited one node, right, or one course here. We are taking it out from the queue. That actually means we are completing one course. So when I'm completing one course, I'll be incrementing the count to plus plus. So, and as I said before, at the end I'll just verify if count is equal to n. That actually means we have done with all courses and it's going to turn true, or else it is false. So this is pretty much the solution. This is pretty much the implementation of the code. So let's try to run this. I hope you got this approach. Let's try to run this. Yeah, it worked. Let's try to use some extra test cases as well. Oh, okay. Let's try to run again. Yeah, it worked. Let's try to submit this. Yeah, it got succeeded. So this is how you write the solution for course schedule. So as I said before, I have used Kahn's algorithm in this, which mainly deals with the integrities of the nodes. So this is how you mainly use queues. You use queue and you just use, it's something like a BFS approach. That's it. But you mainly deal with integrities. So if you like the video, please make sure you like and subscribe. Thank you.